Clients, this is Vijay Khemka. I'm here to talk about introducing a new machine to OpenBMC project. Here we do support OpenBMC in different architectures for BMC platforms. Like we have ASpeed and Novaton for BMC side and Intel servers as well as IBM OpenPower servers for host side, but I'll be mostly talking about ASpeed and Intel combination. That's what I have been using. I've been working along. So feel free to ask if you have any questions along with. So the basic idea about is like any developer can introduce their platform or their machines to this OpenBMC projects. But before that, you should have a basic knowledge about a BMC hardware, Linux kernel, embedded Linux implementations, how C, C++ programming skills, IPMI, which is nothing but a communication management interface between host and that BMCs, dbus, which we are using for inter-process communications inside the BMC software. Yocto is nothing but a build environment or a package provided by the Yocto, which is what we are using here. So either you can just like learn all of these skills and then you can start contributing to this OpenBMC project. My agenda here going to be talk about how a machine layers would look like. Layers is the terms being widely used in terms of Yocto environment, a build. So where you add machines for building your own machines required as per your own configurations. I'll be talking about what kernel changes you would be needing for the basic to start. Do I need a change or not? Basic features which is required for any OpenBMC platforms, which we are supporting through this project. I'll also add a list of other features available, but I will just touch upon, may not be giving you more details in depth. Then I'll also touch upon the continuous integrations, like how you can include your machines into a build system, continuous integration, which gets built based on any changes into the system project. Then I'll add some references and we'll be open for Q&A. You can feel free to ask questions in between as well. I'll be each slides will have its own topic, so I'll add give a chance to people to query right over there. A machine layer. So for any new platform into the OpenBMC projects, there are several platforms available, and if you want to add a new platform, so a better way to start is you create a meta company repo. Like let's assume your company name is ABC. So you create a new repo called meta ABC, and you request that repo into the community in the mailing list for a placeholder. Once you have that repo, then you can add multiple machines under that repo under the same company. So multiple machines can be added in that same repo. So you have to add a machine layer. Let's say your machine name is XYZ or PQR. You can add a meta XYZ, meta PQR into that. You have to add machine configuration recipe changes in the machine layer. Like recipe changes means if any packages changes required or any packages needs to be configured according to your machine requirement, would go under your machine layer. Then you can create a package group, add a package group for your own machine. So the group will have only packages applied to your machine. So you can pick up the common package and enable those packages into your machine groups, machine package groups. Each machine can have its own configurations for different packages. Several machines repo like Meta Intel, Meta IBM, Meta Facebooks are available in the OpenBMC repo. So you can refer that for basic start files or basic things, what all basic things are required. I'll be touching upon in the next slides on some of the basic files. You can see the picture on the right side, and the more detailed picture you can see the next year. So here, like what a machine layer would look like. Let's assume you created a repo called meta abc and you initialize the repo. Then you should have a conf file where you give like a common configuration across all the machines under the same company. Then you have to have a license definition of what are the license you are using for your own development. Then you create a machine layer, which is like a meta xyz. Under the machine layers, you create a conf directory, then which contains configuration about your machines. And some of that BB layers conf, which is nothing but it provides a discovery path, right? You add a path, how all the packages are going to be discovered, from which layers it's being pulled from. All those details will go here. The samples are available, you can just use that. Then you mainly provide your machine level configuration called under the machine xyz.conf. XYZ nothing but your machine name. Here you provide all the details about what SOC you are using, what are the other general configurations you are including. So like everything goes there. What packages, you create a package group, you add, how you are selecting the packages, what variables required, what override, everything goes here. You can also mention about your baud rate or your U-boot version. So like everything, because when you create a project, when you create a machine, whole configuration of your machine goes into this file. Now then you have some of the recipe changes directories. So every projects or every features have its own recipe. But if you want to make some changes according to your own requirement or according to your own machine requirement, the changes will go into this. Like you can append and you can override some of the configuration file. You can pass some of that flag over here. So you can just like add, let's say assume you want to make some changes to the kernel, you add a recipe kernel path and then you provide BB append, what you're changing. Then there is a called xyz machine.cfg is the path where is a file where you enable or disable your kernel config. So you just like you want to add some of the kernel configurations. Basic kernel configuration would be supplied from your SOC. Like if you're using ASpeed is providing some config, but you want to add or enable or disable some of other kernel config can be provided into this file. And then you can just put into the BB append saying, okay, this is my extra configuration. The similar way under the recipe phosphor, there are all the basic features. Most of them are available under recipe phosphor. So let's say you want to make some changes to any of your features, like enabling something or adding some packages or anything like that. Like I'm giving example of console. We have a console feature, and then you may have to provide some configuration for the console feature. What you're using, what baud rate you want. So all those changes, your machine specific configuration file for that particular package would go here so that it can override the existing default packages, the default configuration. So this is how you are going to build your own machine, and you will add corresponding configurations for your images, corresponding for your packages, corresponding details into this machine layer. Once you have this layer available, I'll talk about more details into the how the features would look like. So then you can build your machines based on your own configuration. Any questions so far?
Hey Vijay, I had a quick question. This is Deepak
Sure.
here. So I was wondering, does a new machine necessarily require a new meta layer? In other words, in the example that you have on this slide, if there is, could the XYZ actually be a platform under which there are different variations, each of them being different machines? And could that just be a different .conf file under the machine?
It can be. That's a good question. So it just like yeah, you can under that. Let's assume you don't have meta XVG. You just have meta ABC, and under the conf you can add several meta dot like machine.conf file. You say xyz.conf, pqr.conf. But so I just added here because then if you are doing that way, then for adding any new packages, so like you are modifying any packages under recipe phosphor. So all of those will become a common and it will be applied to all the machines. Then you have to have machine override variables defined in each of the packages or thing. So there are two ways, right? Like you create a common thing, then you parse your machine type or name into your BB append or where you want to add. And or else like you create it separately here, meta xyg, then it will always, and when you are defining that your machine name, you provide this path, the conf xyz.conf path to that to build system, so it will pick up from here. Did I answer your question, Deepak?
Yeah, that helps. Thanks.
Okay, so now let's go to the next item is kernel changes. The very basic question comes: why do I need a kernel change? So for every platform or every board being built has its own hardware design. So it has its own like a kernel config. It has its own devices, IOs, and you want to enable, you want to pick up a particular driver, you want to provide certain parameters, you want to, so you have to have like your own, then only you need changes. A very basic changes is required, define a device tree, which will have a configuration for your own board. So it's like for your particular board, you have a definition, configuration on that device tree. So in the device tree, you have to just create a new device tree file under arch arm boot DTS. A device tree file name should be like this is what we are following and we are using that. And this device tree file name should also be included into the machine name. The machine should know which device name should be picked up. So it's like a speed, BMC, ABC is the company name, XYZ is the machine name, .dts. So you create this file and it'll have all your board specific data like flash info, number of I2C devices being used into your system, list of the GPIO pins you want to enable, the other devices, you are adding some drivers or enabling some drivers for particular devices. All other informations will go here. You can refer, there are a bunch of A-speed BMC device trees for different machines. You can refer those into the kernel tree. What other changes you may need it? So like, let's say you have some device for which the driver is not available into the kernel.org or in the kernel tree, right? So you may have to write your own Linux. You have to introduce a new kernel driver for your particular device. You can, it can be generally I have seen in my experiences, I have to add some certain PM bus drivers which were not available. Or you can add like a CPU specific driver, like a PECI we had added into our system. So these, all those drivers, you can make changes. Some of the things, some of the existing, like kernel is like is keep on growing and every day things, patches are being added. So let's assume that to support your system, you may have to fix some of the bugs or some of the patches needs to be applied. That also can be added into the kernel changes. You have to upstream all the kernel's changes to the kernel.org. So mainly, let's talk about the kernel upstream process. So OpenBMC takes a fork of the kernel from the kernel.org, and it regularly maintains and update that it's Linux A-speed kernel or whatever the SoC you're using from the kernel.org. You can send your patches, your changes to the kernel.org, and include the OpenBMC mailing list. There is in the reference sections how to submit patches for kernel documents listed into the link. You can refer that. How do we add support the package, because kernel has its own requirement of a process of submitting patches. It has detailed documentations. You can go through that. So all along, like if you ask a simple thing is a very basic question, you may just need to add a device tree just for your machine to give a start. And then if based on your own new devices, you can add patches as well as the drivers. Any questions on the kernel side?
So I have a question. So basically, to add a new machine, I first need to add it to the kernel, and then right, it is a specific machine. I need to add its device tree to the kernel,
Yes.
and then it have to be just a cut a version into OpenBMC.
Yes.
Because then add the meta layer in OpenBMC.
So as I said in previous slide here, when you say xyz.conf, where you will say that about which device tree file you are using, and that's generally nothing but called like ASPID BMC dash.
Okay.
You can put your machine name, the dollar. You can put a company name, then dollar machine name. So it will pick up that machine name, and then it will look for that particular file inside the device tree path.
Okay, thank you.
All right. So now I'll touch upon basic features. So now we have added a new machines. We build our Linux kernel, system boots. Now we need the system to behave and the way we want, and we want certain features to be working on for that. So there are basic features which we are. I'm going to touch upon, give little details about, which I have also worked on and I've used it. A host power control. That's the basic base feature of any system where you have a host system. You want to manage the power of the system on off from the BMC. Then there is a Serial-Over-Lan solve, which is being used for that seeing the console of the host. Then comes is the FRUID. The FRU mainly is like a field replaceable unit, and where you have all the data informations. Then we'll talk about sensors, then fan control, and IPMI in-band. Because why I mentioned in-band here, because I will be talking more about in-band packages. I'll touch upon the out-of-band, but I've not used those, so I will not be giving more details on that. Then there's IPMB and firmware upgrade. How do you upgrade your system? So let's talk about the host power control. So in OpenBMC project, we have two packages available for the host power control, like powering the host, controlling the host power and monitoring its states. There's a package called phosphor state manager, and another is x86 power control. As I say that I have used more on that Intel servers, and I'm using the x86 power controls. I'll give much more detail about that. But I'm going to touch upon how the phosphor state manager also being used. So and to use any of phosphor state manager, you need a separate system target for each actions like on, off, or a reset. Target files are like OBMC chassis power off .target. It has power on .target, or you can have other several bunch of targets you can define, and for the particular actions you want to have. So you have to have your own development of each actions daemon or scripts or whatever you want to call into under the target. There's so another package available for this is x86 power control. It implements power control for Intel servers. Remember, I talk about there are multiple machines being used, like Intel servers or open power servers for host. So this package generally covers only for Intel servers. It supports standard controls like on, off, reset, and this can be done via redfish commands. There are redfish commands available to control to do these actions. You can also log into that system via SSH, and for your test purpose, you can test that on and off. You can do that as well. It uses a libgpid. What libgpid means like you need GPIO line names into your kernel device tree. So this libgpid reads the line names and scan through all the GPIOs from the kernel it gets, and then based on the name, it just like take an action and read and all. So you have to have these GPIO line names mentioned into your kernel device tree. If you have those names, then only the kernel would be able to expose this to the libgpid, and then this application would be able to use those lines. So these libgpio, these GPIO line names can be passed via config file if different from the standard name. So like, so whatever the name for a particular line you define into your device tree, you can choose any name. But if you are using the standard name, like for power out GPIO pin, you are using power underscore out, the name I'm spelling out here, or reset out, or a power OK. So then this it will work by default, because it's using, these are the names being used into this application. But if you have different names, then you can provide a mapping of your own name to this hardcore defined name into a configuration JSON file along with this system, along with this package. It supports multiple hosts, and each host should have its own config file. When I say config file, means that you list out that GPIO name. So let's assume you have 4 or 5 hosts you are using, and every host has GPIO for power out. So you name it, each host, like let's say host 0 has power out 0 name, host 1 has power out 1, and like that. So you can provide all this mapping of power out to power out 0, power out to power out 1 for each host config file. So that way, when this program runs, and then it'll refer to that particular pin for a particular instance of that applications of the process. You need to set a certain this variable virtual runtime OBMC host state manager to the chosen package you want to, whatever the package you want to choose for a power control. You have to set this into your config file, into your package group, into your machine configuration file. Any questions over here?
Hi, Vijay. Santosh here.
Yes,
So,
please.
yeah, I have the one question. Whether Phosphor State Manager or x86 power controller supports SC power cycle policies, like the previously the system was on, then make it on, or whether make it always off or on kind of policy?
Yes, so x86 power control supports that power restore policies, and for that, what was the system's last status and all has to be there is another configuration which needs to be provided, or there is another dbus interface has to be updated. So yes, it does support taking those actions when the system starts. It looks for what was the last state of the system, and that information has to be available. I cannot say much like if it is available into the system and you can read it through, and once if it is last state, whatever the policy was, it will take the action of your system.
Okay, thank you.
Hey Vijay, one more question.
Please.
Hi, so this is Supreet. So does the x86 power control needs changes? For example, if the GPIO trigger is instead of active high, it's active low or something like on at the edge triggering falling rising edge, if it's different, does the application itself needs to change?
That's a very good question. I've never come across this change, but I may have to look into, or you may be able to define that falling edge or no, but right now we don't have that support of defining which is it does always work on the standard, whatever the standard way of Intel's machines are doing. But
yeah, just asked because I had to modify it for AMD processors. Just wanted to make sure that I'm doing it the right way. There is no config at this point for those things, right?
Yeah, at this point, no, but I would take that as a good suggestions to include as a feature, because that's a nice thing to have giving a flexibility to your system, how your GPI lines behave, like falling edge or active high.
Yeah, thanks.
Yeah. All right, so let's move to the next features, which has Serial-Over-Lan. This application is being used to see the console of the host system. Mainly in our BMC, we have ways to, connect console to the BMC, or we connect to the SSH to the BMC. So our front end is a BMC and we get access, but we want to access what's happening into the host. If you want to see the console of that, then there is a Serial-Over-Lan which can be used. The OBMC console package is available for these features. Host UART port can be configured into the server.conf file. So like default config file uses a VUART port. VUART is a port provided by ASPID. It's a feature into ASPID chip, which is being used to connect to that host and access the host console. But if you have in your hardware, if you have some different port connected, and you want to access through that particular port, then you can provide a separate server.conf file and put your port details. And if you have different baud rate, you can add those details. So when a system starts, an OBMC console server will be running, which is listening to the console messages from host. And then you need to run a client to access those console messages, or access the whole console from the host. This OBMC console also supports multiple hosts at different UART ports. So like if you have multiple hosts, as I talked about previously, multiple hosts you have available and you want to access those hosts one by one, you can just run that client with different host information. So to enable this feature, you have to set an enable concurrent server flag into your config, into your package configuration to configure this multi-host. Then you have to add a server config files for each host, and then you just run the OBMC client to see that package, see that console. Any question on this? Okay. Next feature is a FRU. So it's a field replaceable unit. So FRU is nothing but like a flash device where it's a device where you keep a board specific information like a product name, part number, serial number. So how do you identify what board is, when it was built, what manufacturer was? So all those details is driven through a standard, like a FRU is a specification through which we like in the BMC being managed, right? So, and to access these data and or to present this data or to read this data from that EEPROM and flash, we have two packages available into our OpenBMC projects. One is IPMI FRU parser, another is entity manager. I'll not give much details. I cannot be able to give much details about the IPMI FRU parser. I have not used that. I have used the entity manager where I can give you more details. But I know like IPMI-FRU parser, it uses a fixed EEPROM path to read the FRU data. So like if you have whatever the EEPROM you have, you just give in the configurations the path, like a CSFS path where the device is being detected along with the I2C channels. And then it'll go and read those files and expose the FRU data. Whereas another approach, another package we have, Entity Manager. Entity Manager, which includes a config. It also has a FRU device application as well as Entity Manager application. Entity Manager is the name of the package. So it provides a FRU device applications for reading the FRU data. It enumerates all available EEPROM in the system and read FRU data for all available FRU devices. So like once you enable this applications, you don't need to give any pathway. It will just go through all the I2C channels based on the standard of the FRU. And it will look for all the EEPROM available devices. It supports 8-bit or 16-bit, both EEPROM. It detects and then scan through that EEPROM and then find out if the device EEPROM is FRU or not. If it is FRU, then it reads its data and it exposed to the dbus all the FRU data details. So it adds an interface into the dbus for a particular device found. You can to enable this feature, you can add chosen package into your machine-specific package group. Any questions on this?
Yes, I have a question, if I may.
Please.
So for Entity Manager, you find out FRU data dynamically, and then I guess you add the sensors to the system basically. Do you need them in the device tree before, or they can be added dynamically to the device tree? Because if it's an ICE.
Yeah, so Entity Manager supports the dynamically addition of the devices. So, and you need a device tree for a basic system to start, right? You need those I2C devices into that your device tree enabling. But Entity Managers also instantiate those I2C devices dynamically if you add into the configuration. So more details about Entity Manager, it's a big section. It will be covered in the following week by James.
Okay, thank you.
All right.
So one more question, Vijay. This is Supreet again.
Yeah.
So is there two different ways of doing this? One using, there is a phosphor-ipmi-FRU package as well. Yeah. And one more is the Entity Manager. So what is that phosphor-ipmi-FRU used for?
Yeah, that's the same thing. As I say, the IPMI-FRU parser. So that package name would be a phosphor-ipmi-FRU. So that is a way where you have to provide your EEPROM path and where your EEPROM there in the system, and then it will read all the FRU data and add into their FRU inventory or IPMI-FRU.
Okay, so I think I saw an email today on the mailing list about someone complaining IPMI-FRU command is not getting printed.
Okay, I expected that question after seeing that email. So yeah, so that talks about accessing those FRU data over via IPMI. And so what these application does is nothing but it puts those FRU data into the dbus in the inventory, right? But IPMI is a separate package which reads which supports the IPMI-FRU command, which reads the data from the FRU devices. So I also replied to that is that currently IPMI-FRU commands are not may not be supporting the all of the interfaces being read by different applications exposed. whereas I see that there are OEM, the override of those commands done by Intel IPMI or Facebook IPMI. They do so they do override those IPMI FRU command, and then they read from that particular interface. So there may be a common design which can be enhanced to support all of that ways of reading this data from the dbus.
Okay. So right now there is no common way of doing it. So it's just over the, you need to create a IPMI OEM recipe and add your IPMI OEM implementation.
For IPMI FRU access command, yes.
Yeah.
Yeah. So that can be enhanced to add the common way of doing into the IPMI.
You mean the phosphor-host-ipmid, right?
Yes, yes,
Okay.
I mean that.
Okay. Thanks.
All right. So let's go to the next section, fan control. So there's another good basic features required for any system. You have a bunch of sensors, temperature sensors, and you want to control the speed of the fan based on your sensors and location, zone, everything, and you want to have a controller. So there is you have another, again, couple of packages available. Phosphor fan presence or a phosphor PID control for this fan controller. I have mainly used phosphor PID controls. I can give details about that. Fan presence, I have not used it, but you can set this virtual OBMC fan management variable into your machine config to set which package you want to use for this feature. The phosphor PID control package can be configured two ways. Let's say either you want, for this particular feature, either you want to provide a standalone config file, a JSON config file, where you can list all your sensors details, what temperatures you want to maintain, what fan speed, how it should be stepwise, PID. All these configurations can go into that standalone single file. Or else if you are using an entity manager where you have all the informations into a single place, and then you can add this config also into that entity manager configurations. But if you're using the entity manager configurations, you have to set a flag called enable configure dbus. What entity manager does is it just pushes all that configuration to the dbus, and then you read from the dbus. So that you have to add it, enable, I tell this the PID controller to read those configurations from that dbus. Then you can you add a fan controller configuration into the entity manager page. I'll just touch upon base sample of addition into the entity manager, but more details about entity manager, I said, would be covered into the next talk by James. So these are the sample configurations. We have three types of temperature sensors listed here. First left most one is type PID. The next two one are the type stepwise. The PID has its own field you have to add details about. So let's say the input temperature is DTS CPU1. For that, you want to control, and these are the parameters you have to provide. On the stepwise is a straightforward where you just say the readings of the DIMM A1 CPU to temperature. If it goes beyond 65, then you set the speed of fan is 10%, 70, then 20%. So like I said, reading is the input of the data, output is the fan speed in the percentage that you put it here. The similarly is for the inlet temperature. So these are the like a sample example of configurations into the entity manager configuration where you put about these fans controller. Any questions here? All right. IPMI. So as we had several questions about IPMI in the previous slide. So IPMI is another basic features which are being used to communicate between host and the BMC. It's a platform management interface. you have to add phosphor-host-ipmid package to enable this feature into your system. So many systems has different hardware. So hardware supported by the ASP is the connections between host and BMCs, which is KCS or a BT. So you have to set that what hardware layer you're using, OBMC host IPMI hardware variable to phosphor-ipmi-kcs or phosphor-ipmi-bt in a machine configuration file. Provide a device ID configuration file for each machine into this path. So each machine or each system can have its own device ID. So the IPMI get device ID commands can reply. So you can identify your system. So you have to provide this your own specific in a format of given this path. You can follow that specification and provide all the field. And then this applications will read this file and provide get a device ID command response. It supports all the standard IPMI commands. When I say all, it means like there might be it's still in the development, and there may be some of the commands missing. It also OEM commands are available from IPMI providers library. So this application reads any library available under IPMI providers. There's a path, and then you can have your own library. So all the OEM specific libraries should be developed by a developer, by user. So you can provide your own OEM. So how OEM commands should be responded, you can provide under this library. Or else if you want to override any of the commands or standard commands for your own particular requirement, you can add into your own library, and you can request for that repo into the company specific IPMI OEM library, and then add your OEM specific command if that's required, or else you can straightforward use whatever the standard commands available through these applications. There are few OEM specific IPMI repos like Intel IPMI OEM. We just talked about the FRU, the way IPMI FRU is being used and how they just override through this repo. And there is a FB IPMI OEM, and there are others also available for reference. If you want to add your own repo or IPMI, you can just refer those repo and add according to your requirement. Any questions on this? All right. So there is another bus, like a platform management bus, IPMB, being used for several IPMB devices. There are IPMB devices in the system, and then for Intel host servers, there is a IME also, which are being accessed through IPMB channel. So it add phosphor-ipmi-IPMB package to enable this feature. It supports both IPMB and IME channels as per specifications. Multiple devices are supported under both IPMB and IME channels. So like if you have multi-host, then you have multiple IMEs, then you can add multiple IMEs under the IME channel, like ID 0, 1, 2, 3, 4. Or you have multiple IPMB devices. Let's say you have several IPMB devices connecting to your system and you want to really communicate with those. So you can add several IPMB devices under the same IPMB channel. I am just on the right side. If you see, I have sample configurations for the channels. So there are two types of channels. One is IME, another is IPMB, where you give a path for a slave path for that IPMB, which you will be able to find, you will be able to see when you add to your device tree. And then you provide your BMC address. What is the BMC address? The slave address. And then you provide that remote address of the system of the device. You need to enable this or add this IPMB dev kernel driver into your device tree for each device you want to communicate through. The sample as we put, you add like IPMB at what address it's being accessed, and then compatibility, and you need to enable this I2C protocols. So like this is basic requirement of IPMB dev driver being used into our system. Add each device details into the package config file. As I said on the right side, you can just add each device into this. Just make this new modification or new additions to this configuration and append into your data layer recipe package. Any questions on this? Okay, so now after you have a system and you want to really make changes or upgrade the image, so you need a firmware upgrade. There are several firmware upgrades are available. So there are certain types of firmwares available into the system which you need to be you want to upgrade. The very basic, like there are some PSUs. There's a phosphor PSU software manager for upgrading all PSUs. There is a phosphor software manager itself or a host software. So in case you want to upgrade the host BIOS or you want to upgrade the BMC, you can add this package. So how do you do that? After you add the package, how do you upgrade that? So there are several steps. First, you get the image. So if you are upgrading to the BMC, I'll be more talking about the phosphor software manager. So in that, we support BMC and BIOS. So for BMC, you can copy your BMC image from a local build directory, and the image could be a start.mtd.tar. It's a tarball which needs to be copied. And then for a BIOS, you have to create a BIOS because BIOS is not being built under your build environment. So you get a BIOS from the OEMs, and then you need to generate a package tarball, which this application understands. So there is a gen biostar tools into the repo, which can be used to generate this package tarball. It will create a tarball name, default name OBMC biostar.gz, or you can also provide your own name into the command and along with the original BIOS image. So you have to, once package tarball is being created, for the BIOS, the system, every platform, every machine has its own way of upgrading the BIOS. Some of them may have some turning off GPIO. How do you access the flash? How do you share the flash between host and the BMC? So all those things are different for different systems. So that's why we have left that decisions to the user how their system needs a BIOS upgrade, scripts or any daemon or any applications which can be running. So you have to add this target like OBMC flash host BIOS service systemd file, which will be called when you activate the upgrade. This system target will be called, and it will execute the platform specific command like you provide a script saying, hey, disable, set this GPIO, then copy, bind the device, then copy, and then unbind it and run some commands. So all this can be put into your script and can run from here. So now here we created an image, either a BMC or a BIOS. For both of them, now after you create the image, you need to, how do you send to the upgrade to the system? So now you have to, you can SCP the image to the BMC target, either a BIOS image or a BMC image, whatever you created. After image copy, once the complete image copied to this path, it will generate an image ID. So you will see that image ID into the temp images. Let's say it generates XXXX. That same image ID you need to put into your next following commands to activate that image. So you execute the bus control command, put that XX into the given bullet on that, and then run this command. It will activate the image for upgrade. Then for a BIOS, it will kick off the systemd unit file, what you defined for BMC, you have to reboot to complete that upgrade. Upgrade can also be done using redfish command as well. There's a redfish command which mentioned here, which can be used to upgrade any of the images. You can, there is a talk on redfish by Gunnar in the following week. where he'll talk about more about how the Redfish and all. You can refer this document, Redfish chip sheet, how to connect to the system via Redfish and what are the basic commands can be used. Any questions on firmware upgrade?
Yeah, I have a question.
Go ahead.
This is Mike Jones. I'm on the PMBus committee, and we're working on defining a file format for upgrading EEPROMs inside regulators, PMBus regulators. And so we're kind of wondering whether this firmware upgrade would be the thing that we would work with to try to do that. It might be a little involved in that power might have to be turned off before the upgrade proceeds to prevent side effects. So it requires some host state management. So I'm just trying to get a general sense of, do you think upgrading permanent settings of regulators could be integrated into this firmware upgrade, or do we need to go do something completely independent from this?
So that's a very good question. Thanks, Mike. In fact, I also had the similar requirement of upgrading those regulators. And yes, so upgrading those regulators, we can include into this because I want to encourage to have this software manager single place and where you can upgrade all the pieces, the way I've included BIOS into the BMC as well. So, but at the same time, now you have to unload the driver for that PSUs to access the device. That decision is still pending and how we want to design that path. But I would really encourage to include into this path. Maybe next feature working for me would be that, adding that.
Our intention is to develop the code that can apply these to the EEPROMs and have all the different vendors of PMBus products test, and then come back to the community and ask for the integration help.
So that, yeah, that will be much easier if you have the process of how those upgrade will happen. Then we can add simply like this, where we will generate the tarball of that image, and then we kick off a system target file, and the target file scripts will take care of upgrading.
Yeah. Okay.
Vijay?
I may contact you a little later after we get
Sure.
farther
Yeah.
in the definition.
Quick time check, 4 minutes.
Sure. Yeah.
Okay.
Okay.
Hi Vijay, I have one
Yeah.
quick question.
Sure.
So regarding firmware upgrade, let's say I want to upgrade one image, BMC image.
Mm-hmm.
Okay. So first time I have updated the images. So second time I want to update the same image, means let's say it will have the same key. Okay.
Mm-hmm.
So each time the images will not reflecting correctly. So we are facing sometimes these issues
Yeah. So that image. So if you when you are upgrading the image, means you have to have a different version of the image. And if the image is having the same version, then it will not upgrade to the system. You have to have some changes. The software updater just check for the version. If the version is same, then it'll throw the log message saying you already running this image.
Yeah. Okay. Vijay. So is there any other way to check upgrade the same image? Because we are doing the same changes in our same build, right?
You just ping me offline. I'll answer that. I have some tricks to do that. We can take care of, but that's not
sure,
supported in this. Okay.
Okay. Thanks.
All right. So now next I'll just touch upon. So I talk about a list of the features which are basically required and which are basically I worked on that. There are a bunch of other features which not many people would be needed, and but it's available into our OpenBMC projects. So there are other features like entity manager, which there will be a talk from the James. There's a entity manager is a feature, is not other, is required if you are using it. And then there's a Redfish you can use. There's a talk from the Gunnar. Then there's IPMI out of band. There's a phosphor-net IPMID, which supports this IPMID out of band. There's a BMC web. applications which are being used, can be used for a web UI access. Is a backend for the web UI and for the Redfish as well. There is a network manager for managing that all the details for the networks. The GPI monitors monitoring all the GPI lines we want to get monitored. There's a cell log, is also a log or event logs which are being managed into the system. There's a host console log, so any console which is coming from that host are being also logged. There's an NVMe manager, phosphor-NVMe manager, which manages that NVMe sensors, monitors the NVMe sensors. Postcode management, there are postcodes which are coming from the system host, are being logged, managed through this feature. Next, I'm going to talk about continuous integration. So continuous integrations is the system where you there is a wiki page for the continuous integrations. It helps catching any build break as early as new code submission. So you add a machine to an OpenBMC build script. Your new machine, whichever you just created, add to this OpenBMC build script, and then it will build each machine is listed for every patch submitted to the OpenBMC review. So if you submit a review, patch review, your machine also gets built. If something is breaking your machines, it can be caught right on there, and a developer would be notified and then has to be fixed. So you don't need to maintain, like let's say 3 months you are not doing any development on this, and your system should still work with that latest image. That's the advantage of this, putting your machine into the continuous integrations. All right, I have some references for the documents. Initial setup and build. How do you set up your system and build? Contributing guidelines. How do you contribute to the OpenBMC projects? What are the coding styles and conventions being used? How do you submit the kernel patch, as I talked about in the previous slides? You can add kernel patches, and there is a Redfish commands. What are the cheat sheet for the Redfish commands? I'm done with my talk on this. If you have any questions, you can feel free to ask, or you can reach me out on IRC, or you can send me an email, or just ping me for any questions I couldn't answer here. I'll be able to give more details via email or IRC.
Thanks, Vijay. I think we are out of time. I request all the audience to submit any questions offline. Thank you all.
Thank you all.